All right, let's begin working with some series of non-rigid transformations, combining them in sequence. And we can see here in Explain 2 Part B that we're being walked through a verbal description first before we start attacking our graph here. So number 1 says the first transformation is A, and whenever they put a kind of something slash something else in brackets like that, you know they're basically asking you to choose. So which of it, guys? Is it horizontal or vertical stretch by a factor of what? And so again, we're looking for the first transformation. That's this one right here. Okay? And they want to know which one has been stretched. So if I look at these two coordinates, 3x versus y, the one that's had a number multiplied by it is the horizontal. So we're going to circle horizontal, and the number that's been multiplied by is by a factor of 3. So over on our graph here, you're going to actually see, almost like silly putty, okay, a stretch horizontally with that in mind. So we're going to take whatever it is, it looks like it's another triangle, and we're going to basically stretch it horizontally 3 times its normal length. Then it says apply the stretch, label the image. We're going to do that in a second, but the image, remember, after one transformation is going to have prime notation of A prime, B prime, C prime. And then when we apply our second transformation, that's this second set of coordinates up top here, that is a dilation, and that's when we scale both the x and the y by a factor of, and it looks like a factor of 1/2. So in that case, it's actually going to take half of each coordinate, so it's going to shrink down in size after we've stretched it horizontally, and combined with a reflection, okay? The reflection that you can see there is notated by the fact that one of those coordinates up top has a negative sign around it, see? So it's the y coordinate that is changing sign, and so hopefully you remember from our knowledge about which coordinate changes. When the y coordinate changes, it's a reflection, and we can just write ourselves a little note here that it's going to be over the x-axis. Then we're going to apply that transformation to the end result of transformation number 1. So we're going to apply it to actually A prime, B prime, C prime, and then we're going to label the image just like we did before. I'm going to make my final one in red, but after 2 transformations it'll be A double prime, B double prime, and C double prime. And you can always know how many primes you should have by counting the number of transformations, counting basically the number of arrows that happened in your sequence here of non-rigid transformations. Okay, so that's the verbal description of what's going to be happening. Now let's actually do it. If we move over to our graph, what I would highly recommend you doing is giving yourself some room, and I'm going to do it, I think, down below here, our graph. I'm going to move up a little bit, and make a list of points each time that. Okay, so our points were A, B, and C here, and I'm going to make a big long list of these transformations. So A, B, and C started at A is 0, -2, B is -2, -4, and C is -4, -4. You'll write much neater than I can with my stylus, but let's figure out what those are going to get transformed to. So again, thinking about what our transformation is over here, okay, our first transformation is the multiply the x coordinate by 3, and notice we're leaving y alone, we're not doing anything to y, okay? So we're going to move back over to our graph, and we are going to multiply all these x coordinates by 3. So 0 times 3 is a 0 still. -2 times 3 is -6, and -4 times 3 is -12. So you can see now why they put the axes going all the way over to that direction. It looks a little weird, kind of off-center, but obviously they did it on purpose. And then remember, we're leaving y alone. So -6, -4, and -12, -4. So this is going to be, oops, I forgot to put my labels. Let's make sure we stick those in. A prime, B prime, and C prime. And let's go ahead and graph that stretched out, remember, with regard to the x, stretched out triangle. So A prime is actually going to stay exactly where it is. B prime is going to land all the way over here on the other side of C. And C prime is going to be over here at -12 on that same horizontal line. So I think like what I was talking about with the silly putty, you can see that this triangle has kind of been stretched out here. So there's A prime, B prime, C prime. Next thing we want to do is we want to dilate with a factor of 1/2. So actually it's going to kind of get smaller, and it is going to also reflect at the same time. So A double prime, B double prime, and C double prime. We're going to cut each of those coordinates in half. And as we cut them in half, we are also going to change the sign of the y coordinates. So half of 0 is 0, half of -2 is -1, but change its sign so it's going to be +1. Half of -6 is -3. Half of -4 is -2, but change its sign to +2. That's the reflection piece. -12, half of that is -6. And then half of -4 is back to -2, but again reflected to +2. So let's plot those final 3 points. I'm going to do it in red because that is our final image triangle that we're going to have here. So 0, 1 is over here, -3, 2 is here, and -6, 2 is here. So it is still stretched out from where it started, and it is reflected, but also smaller than the blue triangle. So that's going to be our final. Make sure that you label them. A double prime, this is our B double prime, and there's our C double prime. Okay, so that's a stage combination of non-rigid transformations. In our next slide, we're going to do the exact same thing for your turn, number 11. Looking at it, you can see 3 arrows drawn above the grid there, so we're going to have even more lists of points than we did in this one. We only had 3 different lists of points because we had our pre-image and then image 1 prime and then image double prime. For your turn 11, we're actually going to have 3 of those lists, so make sure you have some good space or use some separate paper. Okay, so that's our next slide. Okay, here on your turn 11, we're doing another sequence of non-rigid transformations, and what we want to make sure that we do is follow these very carefully in the right order. Again, I will just bring to your attention the fact that there are 3 arrows that we see here, so by the time we're done, we're going to have triple primes on all of our points. When there's a sequence of this many non-rigid, it's okay with me, you guys, if we have the coordinate forms given to us, if we just put them in a list and then just plot the final image. It gets a little bit confusing, and we did it in the last one because I just wanted to show you the non-rigid transformation, you know, like pictorially, but it gets a little confusing when you have so many figures on the same grid at the same time. So again, I'm okay if you just want to make a list of points like we did and then just plot the final one. So again, we're going to start with making our list. So A, B, and C. A starts at 2, 2. B starts at 3, 2. And C starts at 2, 5. And our first transformation to A prime, B prime, C prime is going to take and subtract 1 from each of those coordinates. So 1, 1, 2, 1, oops, forgot a parenthesis on the B, sorry about that, and 1, 4. So that's going to be a translation, as you know. Then the next transformation is going to take and multiply the x coordinate by 3. Oops, there's A double prime, B double prime, and C double prime. So Multiply the x coordinate by 3, so we've got 3, 6, and 3, and it'll be leaving the y alone, 3, 1, 6, 1, and 3, 4. And then finally, and this is where we want to draw our last one here, a triple prime here is going to be transformation of negative x to negative y. And again, this is all in sequence, so from 1 ABC, we do the first transformation to give this. Then for the next transformation, we start with A prime, B prime, C prime, and we do the next transformation to get our double prime. So we're doing it in stages, okay? So we've got A triple prime, B triple prime, and C triple prime. And that is finally going to land at making each of those the opposite, negative 3, negative 1, negative 6, negative 1, and negative 3, negative 4. And again, I'm going to do my final one in red, and we're going to land those points on the grid now. Negative 3, negative 1 is here. There's my A, 1, 2, 3 primes. B is negative 6, negative 1, and that's here. And that is B triple prime, and then C triple prime is negative 3, but negative 4, which is here. So as far as what's happened to this figure, remember we can look back at the types of transformations that we used. In this first one we have, in this first one we have transformed it by translating it along a vector. Then we stretched it out so you can see why it's not quite so skinny. It's a much fatter triangle now. And then this last one, remember, is the coordinate form for a rotation 180 degrees. So it moved from quadrant 1 up here down to quadrant 3 around the origin. So that's it, you guys, for your turn number 11. For number 12, looks like you only have 2 transformations, so it won't take you as long. But do make that list of points like we did so that you can kind of follow stage by stage. Okay? Good luck! Okay, and I just want to add, as I was rewatching this video before posting it for you guys, I realized that I actually reversed coordinates B and C, so sorry about that. Just make sure that you know that the list for B through B triple prime should actually be C through C triple prime and vice versa for C. So down here actually we land with C triple prime down in this corner and B triple prime. Sorry about that, you guys. Teachers are not perfect. Bye.